horizontal tangent line problem. Recently, in our pre-calculus class, we had this problem right here. For the following function, find the approximate interval over which it is decreasing. And we have a cubic function, f of x equals 1/10 of quantity x cubed minus 6x squared minus 15x plus 18. And we have 4 multiple choice options here. And what we're basically looking at is a cubic function that has a positive coefficient. And just for reference, let's see here, let's try to get this thing straight here. Okay. But a cubic function, a parent cubic function goes up like this from negative infinity, going up, and then just makes a little jog here at the origin and continues up. That's basically what a parent cubic function looks like. But for it to have an interval over which the function is decreasing, what we're going to have is something that looks more like this. And that would be a function that starts like this, comes up, makes a jog, makes a decrease, and then ends up going back up like this. So in order to have a decreasing interval, we'd have to have a relative maximum here, somewhere here, and to the right, another relative minimum. And so between the relative maximum and the relative minimum is going to be the interval over which the function is increasing. And so obviously, it's going to have to be answer A, B, or C. Now, again, I told my class that this problem could be solved with a calculator in pre-calculus, but in calculus class, we can actually solve this problem using calculus without a calculator. So we're going to do this by finding horizontal tangent lines. And to do that, we're going to take the derivative of this function here. And so our derivative is going to be f prime of x equals 1/10. And 1/10 is going to be our constant factor to everything inside. So x cubed becomes 3x squared differentiated, and negative 6x squared becomes negative 12x, and negative 15x becomes minus 15. And the derivative of a constant, in this case 18, is 0. So to find the horizontal tangent lines, we are going to set this derivative equal to 0, because wherever the derivative is 0, we're going to have a horizontal tangent line. So we have 0 equals 1/10 times 3x squared minus 12x minus 15. And we're going to go about solving for x. First of all, multiplying both sides of this equation by 10, we're going to have 0 equals 3x squared minus 12x minus 15. That's the thing about having one side set to 0. We can multiply and divide at will and not affect the 0 at all. Okay, the next thing we're going to do on the right side is find a common factor for this quadratic trinomial, and that common factor will be 3. So you have 3 times quantity x squared minus 4x minus 5. Next, we're going to divide both sides of this equation by 3, and again we get 0 equals x squared minus 4x minus 5. Now we're going to attempt to factor this smaller, less complicated quadratic trinomial. And for that, we're going to have factors of x squared are x and x, and factors of negative 5. Well, we're going to try, it's going to be negative 5 times 1, or negative 1 times 5. We're going to try negative 5 times 1. And if this works out, let's see, we have negative 5x plus x. So this is going to be it right here. And so using zero factor property of algebra, we know that x minus 5 equals 0. And likewise, we know that x plus 1 equals 0. In solving for x, we have x equals 5 and x equals negative 1. And where do we see negative 1 and 5? Well, we see this right here. So what this looks like is if we make a graph of this function here, it's going to look qualitatively something like this. Okay, we have negative 1 here on the left, so that's negative 1. We have 5 here on the right. So we're going to have a function that goes up here and peaks at negative 1 and goes down, decreases all the way to x equals 5, and then resumes its upward trend from there. And so our function is going to be decreasing over the interval from over the open interval. So we would write this as decreasing on open interval negative 1 to 5. Well, this is interesting. The problem here, it says find the approximate interval. Well, this is exactly the interval, the open interval negative 1 to 5. So that's a nice little calculus problem that came from our pre-calculus test. So I hope this has been a nice little helpful introduction, perhaps, to horizontal tangent lines. Thanks for viewing.